各位中华经济研究院的采购经理人，大家好。这部分的座谈将由意法半导体台湾区总经理 Giuseppe Izzo 主讲 Insight on Automotive Technologies， 而我是意法半导体台湾区公共事务经理 Cindy。很开心能借由这机会概述意法半导体。以下将由英文介绍。I'm pleased to be here with Giuseppe Izzo on this automotive topic. For the first part, I could like to take this opportunity to brief my company, a global semiconductor supplier, one of the key contributors in automotive industry. It is ST Microelectronics. In ST, we have over 50,000 employees. In the ecosystem, we cover 4 blocks. Design capability with more 9,500 R&Ds. We invest in-house manufacturing with 40 sites for front-end and back-end to serve over 200,000 customers by over 80 sales and marketing sites. In 2023, revenue performance is 17.3 billion. ST is a member of United Nations Global Compact and a member of Responsible Business Alliance. Our company has a significant global presence with an international footprint. As I mentioned, there are 14 in-house manufacturing, including 7 locations for wafer productions. In the chart marked blue, 2 in Italy, 3 in France, and 1 each in Sweden and Singapore. Additionally, we have 7 sites dedicated to back-end process, such as testing and assembly, across Europe and Asia, here marked in yellow. The market strategy. As a semiconductor component supplier, our mission is to deliver electronics solutions that enhance people's life everywhere. Automotive as the topic today, Mr. Izzo will share the insights. We also cover industrial, personal electronics, communication equipment, computers, and peripherals. Sustainability. Sustainability has been engraved in our business model and the cultures for over 30 years. ST was among the first to join emerging standards and reporting our progress since 1997. Our CEO had the vision of embedding sustainability into ST business model at a very early stage. It was part of his personal visions and has given ST a competitive advantage in an industrial well known for high energy consumption and the use of a natural resource. And the way ST approach to sustainability. ST, we create technology for a sustainable world in a sustainable way. First, creating technology and design responsible products that play a key role in solving environmental and social challenges. The second, to priority people be ensuring with health, safety, and well-being, and the commitment to carbon neutrality. The third, we creating long-term value for stakeholders, all shareholders, and partners. We commit to be the first in the semiconductor industry to be carbon neutral and sourcing 100% renewable energy by 2027. More guiding principles and 24 sustainability goals are detailed in our annual sustainability report and is available in our website. Please free to take a look. Now I turn the stage to automotive sections. Please join me to welcome the Regional Vice President of ST Asia Pacific, Mr. Giuseppe Izzo.
Thank you, Cindy. In the next section, I will show you a few insights about the automotive market and how the industry, in particular our company, ST Microelectronics, address these specific opportunities. So in our specific case, we are everywhere in a car with more than 3,000 components on average each car. And we address the areas like comfort with more than 1,000 components. When we talk about comfort, we talk about the body and the internal part of the vehicle. The safety with more than 1,000 components. Here we address areas like airbag, electronic power steering, ABS, and so on and so forth. Then navigation with more than 500 components. And more recently, we have diversified our activities into electrification with more than 600 components and infrastructures, external battery charger, and so on and so forth. Up to 5-6 years ago, let's say up to the COVID, that was the defining line between the old and the new world in digital vehicles. 70% or more of the efforts in our company was about the traditional car design and development, and 30% about digitalization and electrification. As we moved into the COVID, new opportunities unfolded about the electric vehicles and connected vehicles. So therefore, now the time spent and the energy and resources were about 50% on traditional cars and grew up to 50% in the electrification and digitalization. As we move forward, this proportion is taking up more space, so we see more than 60% of efforts today being spent on these new platforms that are more connected cars and electrified electric cars, and 40% still spent on traditional vehicles. When we talk about new way of making a car, new way of driving cars, new way of owning cars, we talk generally about smart driving systems. And these smart driving systems are possible thanks to 3 or 4 key ingredients. First of all, microcontrollers, then we have the analog drivers, and then we have the power stage. Okay, so these are the building block of every automotive application. In automotive, we always drive what we say inductive loads that can be motors, can be moving parts, can be an engine, and all these things are always addressed electronically with these 3 building blocks: microcontrollers, driving analog products, and power stage. Now, in ST, we started in the mid-80s to develop a technology called BCD, mixed technology, that was created, demanded in Italy by ST, that was addressing the part in between the microcontroller and the power. So what we say analog controllers or buffers. So this new technology created a step forward in the automotive industry, and over the past 30 plus years, we have shipped billions of units based on these technologies, not only in semiconductors. We have derived also drawn also products that go into other applications that can be computers, or can be peripheral of computers, or can be infrastructures, whatever. So we also have progressed from 4 micron from the first BCD1 technology in production today with 110 nanometers, and the technology has been shared. It's an industry standard now. It has been shared with other companies. On the microcontroller side, we try to foster customer partnerships. So we try to define what really customer needs, what the customer needs, and we also have a comprehensive product roadmap on that. and we do everything by ourselves. So we develop, design, develop, and make the products that we then bring to the market. About power, the third block of the smart driving, in the past, we saw that the power occupied about 40% of the semiconductors used in a vehicle. The major components were MOSFETs and IGBTs. And we saw that towards the COVID period, 2020, so we saw the birth of generation of components called silicon carbide MOSFETs. Right? And as we move forward, we see that power now takes up to 50% of the semiconductors used in a car, and we see also the growth of the silicon carbide versus the MOSFETs, traditional MOSFETs, because of the electrification is bringing about these needs of using more efficient new technologies that are based on new compounds called silicon carbide in this case. The design of a car is also changing substantially. Right? We are coming from so-called linear or functional implementation of electronics in a distributed architecture to so-called domain architecture of a car. What is the difference? Today, when we open a car or open the engine and so on, we see that for each function, there is a so-called ECU, electronic control unit, that is typically a black box that is functioning or operating or supporting the function that it is dedicated to. For example, the engine management will have an ECU for engine management. The seat as an ECU for seat movement, and so on and so forth. So functional linear implementation of semiconductors in the past, now moving to a so-called domain architecture. That the meaning is that we group in a specific area, that can be the door of a car, or can be the engine overall of the car, or can be the safety block of a car. We group the functions and we try to put intelligence, central intelligence, and distribute the lighter electronics to each single function. So that's a major step in going from distributed architecture to domain architecture, and that's not the end of it yet. For example, when we talk about the electrification of vehicle, we see that the platform, the car platform, is substantially modified, simplified. So if we look at conventional car, traditional car, we have about, in very sophisticated cars, up to 100,000 components. And when we look at the electric vehicles, the structure is much more simplified. We have three building blocks, basically. We have motors with what we call traction inverter, that is the electronic part assisting the motor. Then we have the batteries with battery charger, onboard charging, and external charger. And we have the gearbox. So it's much more simplified, requiring much less components, and also much less steps in manufacturing. Now, this has been so far the evolution of the automotive. But as we speak, the industry is going through also another transformation. In particular, we see innovation also in not only in connected electrified cars, but also in conventional cars. We see major steps forward in comfort, in safety, in autonomous driving as well, and connectivity. We see also, as we said, the growth of the electrified vehicles. And then, obviously, the digital and connected cars is by now what we sit in, what we drive every day. This transformation is bringing about another design concept, design modification, that goes from distributed architecture, and as I spoke, linear functional implementation, to domain architecture, now moving to zone architecture, because an electric car, as I said, presents a much more simplified structure, much more simplified platform, and therefore it's much easier to define 4 zones, not like rear, left, rear, right, front, left, front, right. And in these new zones, we gather all the electronics serving the various blocks of the platform itself. Now, this is more or less what automotive is about. In the next section, I will speak on behalf of the European Chamber of Commerce in Taiwan, that I am serving as the chairman for last year and this year. And I have been around in this organization for a long period of time. And here with this organization, where we are very active, both in e-mobility and in energy transformation related to the mobility, we try to put up a proposal for a better or more complete or more profound cooperation between Taiwan and Europe. So I call this small presentation drawing inspiration from Europe for Taiwan's EV industry. As we know, Taiwan has regulations and laws that are calling on, first of all, changing or modifying or putting on the road public vehicles, all electric by 2030, all electric scooters by 2035, and then by 2040 or 50, all vehicles on the road must be electric. Now, in the next few slides, I will give some hints on what are the possible areas of cooperation between Taiwan and EU on the top of what is going on right now. So we will see a little bit the global and regional EV trends, the European automotive legacy and EV innovation, and Taiwan and EU, Europe in particular, what are the potential opportunities for EV partnerships. So first of all, we look at the global and regional EV trends. As we know, over the past decades, there has been a sharp increase in the EV business. So we call the rise of the EV globally, where China has taken the share. China has been very active. It is very active. There have been a lot of stories going on there with a big dynamic of companies in electric cars and potentially becoming very international. So we have seen this trend happening so far and to continue as we move forward. Now, when we look at it globally, we see, for example, on the left side of this slide, that the combination of battery electric vehicles and plug-in hybrid vehicles have taken about 14.8, 15% of share out of all the vehicles sold in the past year, in 2023. And we see in particular that the hybrid EV and plug-in hybrid have taken more share than the others, but the battery electric vehicles are also growing proportionally, while obviously the gasoline and the petrol and the diesel cars are decreasing their share. Now, this is both globally and in Europe is pretty much the same. Now, when we look at the situation from the country point of view, though China is taking the lion's share of the electric vehicles, actually it's not proportionally is not the #1 country in the world for the usage of electric vehicles. #1 is Norway in Europe, with 88% of the vehicles being electric. Sweden is #2, Germany #3, China only comes in the 4th place, and then we have United Kingdom and other countries. As we see, also United States is lagging behind with only 8% of cars sold being electric. Now, why is Europe at this level of leadership, let's say, in the usage of electric vehicles? There are reasons related to the history and to the legacy of the European automotive industry. In particular, we saw that Norway takes up the first position in the rank of countries using electric vehicles. And why is that? The story in Norway started in the mid-80s when the professor from local university, Professor Rostvik, that is now an emeritus professor, with a couple of guys, pop stars from a group called Haha. And they imported a car from Italy, an electric Panda that is still in production, where the back seat of the Panda were replaced by battery that 2 days for charging and only had an autonomy of 20 kilometers. So they started driving the car, driving around Oslo, not being authorized, so started the civil disobedience campaign, and they did not pay parking lots or tolls. So they demanded free use of toll roads, no import tax, free parking, public charging stations, access to bus lines, pretty much what we demand today for electric vehicles. And they got many fines by police, and the car was confiscated. So once the car was confiscated, the car itself was put on a public auction, was purchased not by these people, but by their supporters that gave them the car back so that they could restart this campaign of disobedience. And this story went on 14, 15 times until government in Norway understood the need of transitioning, of transforming the industry from the past of endothermal combustion engines to electric platforms. Though, and despite the fact that Norway is one of the largest producers of oil in the world, okay? So despite that fact, they are also the #1 in the world for the usage of electric vehicles. In this process, of course, they are favored, or they have unquestionable advantages, like all these. Most of their energy in Norway comes from renewable sources, and 10% from the wind, the rest from hydroelectric plants. So the transition to net zero for them is a lot easier to implement because they have already the infrastructure on the renewables, okay? And ideally, Taiwan can be in that domain and direction, though I believe it's very difficult because the industrial clusters of Taiwan are very different from the industrial clusters of Norway. Second point that is also in favor of their transition to the EV revolution is that now the government has put heavy tax, import duties, and car registration taxes that combined together make the traditional car much more expensive than in most countries. They also waive duties, these duties. And so by doing so, Norway is effectively subsidizing the electric vehicle purchases. They offer free parking, more than 22,000 charging stations, and more chargers to come, okay, especially in gyms, in universities, on highways, or restaurants, or whatever leisure areas may be. The second plank, the second area of the European model is the Italian automotive mastering, right? Where the elegance and precision meet together to create objects of art. So I am from Italy, and originally, and so I can share with you the concept that the Italian engineers are really excellent in mechanics and also in crafting and more pieces of art out of any metal, any mechanical situation. So they can combine this ability to be excellent mechanics with the ability to think artistically to something they make. So this is what I say the dawn of the Italian automotive and modern automotive started from this mechanical ability, mechanical artistry, right, where meticulous assembly and fine-tuning of engines meet with aerodynamic requirements, with transmission requirements. So precision, mechanics, and art blend together to make these very beautiful objects, moving objects, okay? So obviously innovative technology from advanced materials, right, and like carbon fiber and or other materials also play a crucial role in this evolution. And also in Italy, we have the legacy of racing, car racing, where the milliseconds really count. They are important. I remember when I was a small boy, in every city of Italy, there were car racings. I went with my dad, with my father, to see this in my little hometown in the south of Italy. And then, obviously, for security reasons, this has completely changed. Now there are circuits like Monza, like Imola, where the Italian car companies can practice these concepts of precision, of speed, of elegance together. Okay, so this is important. The powerhouses of the Italian engineering are more or less three. The Ferrari, that is very well known worldwide, Lamborghini, equally well known, and Bugatti. And so three companies with the same objective of producing art in a car. And, Ferrari were passion and precision with commitment to innovation. Right? They keep striving, keep innovating, keep bringing things to the market that are very attractive to kids, to adults, to everybody. Okay, so dream. Ferrari is a dream more than a car. Then we have Lamborghini, where they are very bold and audacious. Okay, they always push beyond the limits of what is possible. And in many ways, they are beyond Ferrari. And then we have the tradition of Bugatti, that's a testament to the brand's legacy of combining high performance with luxurious design. All these companies are on track for the transition to electrification. It's very difficult to imagine Ferrari that does not roar, does not make the sound, but maybe they will make one electronically. In any case, they are committed to the transition to an electric platform, and they are moving towards it, especially Ferrari. Then the third area of the European evolution in automotive is Germany, and their excellence in leadership, global leadership in automotive. Okay, German engineering is based on many different concepts like innovation, like reliability, safety, design, robustness. Right? When combining these elements with Italian art, you can imagine that European cars are really an incredible product. Okay, and obviously the EV transition brings a big opportunity to Germany, and not only Germany, and because this new transition can be approached with renewed concepts of design, of technologies, of safety, of manufacturing, and so on and so forth. So the European innovation in automotive is there and has strengths, weaknesses, and there are opportunities, there are threats. Okay, the strength obviously is the history and of the automotive, as we said, and the current EV market growth. To talk about the history, just to say, Mr. Benz started the first car company in 1835. So it's more than 100 and almost 200 years ago. So that's what history means in this case, okay, of automotive in Europe. And obviously the current EV transition is another opportunity, another strong point with technologies for this industry in Europe. Then on the weakness side, there is that, as I said before, when we move to a combustion engine, traditional engine, to a modern one, we have much less components. We have much more simplified infrastructure. So this brings challenges to the existing skill sets and infrastructure of the automotive industry in Europe. Okay, if every car is electrified, so many people will not have jobs. Okay, the manufacturing infrastructures will require much less investments and much less workforce. Opportunities are there with the EV that is opening new technological advancements and market expansion, and obviously on the challenge and the threat side, there is the emergence of new platforms. Every time there is a transition, every time there is a transformation of an industry, many companies disappear and many newcomers will appear. Okay, and these many newcomers are now coming from new regions, right, or new markets. That can be the Asian markets, can be China, as we have seen before. So these are all overall the considerations to make about the European automotive industry. When we talk about possible partnerships between Taiwan and European and Europe in general, European companies, European countries, what are the strengths of Taiwan and to match with the European history as we have seen? Obviously, Taiwan has a very strong strong ability to handle the international supply chains. Okay, so Taiwan is central in many sectors in the global supply chain and in the restructuring of supply chain. So semiconductors expertise, for example, and presence on the global markets is a key point for Taiwan, but also the ability to understand and develop and deploy the mechanisms of the global supply chains is another very strong point in Taiwan. So Taiwan and Europe could share goals like market growth and sustainability goals. For example, both Taiwan is moving towards net zero by 2050. Europe equally is moving in that dimension with the Green Deal and so on and so forth. And so we can have many different areas of collaboration. For example, in the batteries, battery material innovation and recycling. We already see many Taiwanese investments in Europe in this area, particularly in France. So therefore, this could be evolving and expanding and creating synergies between these two blocks. Okay, the Taiwanese ability to create technologies, leading technologies globally, and being a master country in the global supply chain, and Europe with the legacy, with the ability to make new products, and the ability to innovate, and so on and so forth. So the future of Taiwan Europe EV collaboration can go through strategic alliances, exploring potential strategic alliances between Taiwan and European companies can lead obviously to mutually beneficial outcomes in the EV sector. And obviously sharing knowledge and technology between Taiwan and Europe can also accelerate the innovation and drive the global competitiveness of both regions. So I do believe that there are many different opportunities there. I do believe that e-mobility 2035 that has been put on the way by TAITRA with Taiwan government towards development of the electrification of transportation in Taiwan and the participation in the global supply chain can find Europe as a destination and can find many European companies as partners, and therefore to grow together towards these very interesting market opportunities. Thank you very much for listening to me, and if you have any questions, you can always reach me in my company, that is ST Microelectronics. Thank you.
Pepe, I saw that in your slide, that's an interesting topic. You mentioned that Taiwan's supply chain can be cooperated with Europe, especially for the EV part company or enterprise, right? But I'm wondering that, CBAN just imposed, and if our country does not investment their factory in Europe, do we have the competitive to sell our EV power in Europe? Seems in Taiwan we don't have a lot of green power. So what is your view about this topic, or did you have some suggestion to us?
Well, the CBAM is one part of the equation, okay, one part of the situation that is addressed already by many Taiwanese companies and will be progressively complying. I am sure that the Taiwanese companies are all very sensitive about this topic, and therefore they will match the European requirements when we talk about exporting products from Taiwan to Europe, okay, or Taiwanese products to Europe. Now, the question to me that is much more interesting is that there is a supply chain restructuring going on in the world, okay? So many countries are reshoring products into their own geographies. And automotive is one of these sectors where we see this repatriation, this restructuring of supply chain. Now, how will Taiwan play in this role? As we know, as I said before, Taiwan has many leading components and technologies, globally leading components and technologies that have to fit in this supply chain. And therefore, I believe that the ability of the Taiwanese to structure marketing channels is there, but I believe the best is to make investments in Europe, for example. No, Taiwan does not have very large investments in Europe. Now, with semiconductor investments, with battery investments, the situation is gradually changing. But we do expect more investments as FDI, direct investments directly in Europe, or with joint ventures, collaborations, partnerships with local companies that can bring the Taiwanese into the new supply chains. This is the way I believe Taiwanese companies will have to implement, and I am sure that many of them will do so. I do expect increasing FDI, right? So, in particular, Europe has been traditionally a weak area for Taiwanese investments. Automotive may bring a good opportunity for these Taiwanese enterprises. For example, in semiconductors, in motors, in many other sectors, in computers, onboard computers of an electric car. So all these are possible opportunities for Taiwan that have to be played. And in this conjunction between FDI, supply chain restructuring, CBAM, and so on. So the CBAM is one part of the equation, but not the only one. And I believe that the Taiwanese companies have all the ingredients to be very successful in this structuring of supply chain.
You give us a very good suggestion. So you mean that maybe we can cooperate or build some ecosystem from the supply chain that the EV park enterprise can be cooperate with Taiwan semiconductor industry, then maybe cooperate with Europe tier one.
For example, this is a good example. I also believe that Taiwan has key technologies to share with the rest of the world, and Europe has not been an area of focus, except for a few cases, one or two relevant cases. Europe has not been a significant area of or destination of Taiwanese investments. I give you an example, okay? The European companies invest in Taiwan about 72 billion US dollars, being the number one investors in Taiwan. The second one is America with less than 36%. And the Taiwanese invest in Europe maybe less than $10 billion. Now with semiconductor investments, with battery investments, this is changing. So building up FDIs to $10 billion, $12 billion. But there is a very large gap, this proportion there, that the Taiwanese can bridge, can compensate by investing more. And I believe that Europe is potentially good because automotive is there, but also aerospace is there, medical is there. So it's not only a matter of automotive being the largest industry in Europe, but I believe that the Taiwanese companies have the potential to be successful if they keep this in mind, that Europe is a friendly area for investments, okay? So I don't think it's necessary to think as Europe as something very far from the Taiwanese mentality. Europe can welcome the Taiwanese investments and accommodate the Taiwanese efforts in a very nice way.
Thank you for giving us this example. It's so pity that in July, because the typhoon, we cancel the speech. So I shoot this question for our managers. Well, I always call him Pepe because he like a friend and like mentor to me. He teach me a lot of. So I'm very grateful. Thank you for giving us the opportunity to record it and give us these answers and suggestions.
Thank you very much, and I hope to come to see you to make a presentation in presence. Okay,
Thank you.
we'll find the opportunity. Thank you.
Thank you.